Welcome back, fellow NASA HUNCH educators and students. My name is Miss Brittany Koger, and I'm going to be walking you through the last investigation station, number 3, for our Lunar Scooter Wheel project. This is our design project, or part of this project, okay? So this is where we're going to be putting our ideas, all of our research that we have done, we're going to be putting it on paper. So you're going to need some large paper for your students to, and you're going to need some measuring tools because we got to get the exact measurements down on paper, okay? So I'm going to show you exactly what I did. Hopefully this camera will zoom in on my hands as I do this with my students, and I show you how to do this with your students. So we're going to put our paper, or our designs on paper. Is called a blueprint, okay? Engineers come up with blueprints. Before they go build a building, there has to be a blueprint on how they're going to build it. So this is our blueprint. This is what we're going to use for our CAD program. And here at my school, our end goal was to 3D print our tire. That was my end goal. And I use Tinkercad as that program. That is absolutely free, whether you have 3D printers or not. It is nice to get your students to just get into a CAD program and to work on a CAD program. This one's absolutely free. You can set up classrooms. There's all kinds of YouTube videos. You can Google things. It is so helpful. Tinkercad is amazing. It is such a wonderful CAD program for elementary age and middle school age students who have never worked with a CAD program before. So I encourage you to do that and get set up on that. And we're going to be putting our designs in our CAD program in the end. Okay. All right. So I'm going to show you guys kind of how I did this. I'm going to use a Sharpie here, and I'm just going to kind of do the marks. I'm not going to try to get it to zoom in on my hands. I'm just going to do these marks, and I'm going to show you how I did it. All right. Okay. So we know we are doing a scooter. So a scooter is not as big as a bicycle or a car tire or even a lawnmower tire. This is going to be a smaller tire. The diameter cannot be larger than 18 inches. Remember, diameter is across the tire from one side to the next. The length of the tire that we did, that is our diameter. So I do encourage you to go back to your weight and measurement slides and get those diameters and the different measurements in your head. Because like that dirt bike tire, the width of it was really good, but the diameter was not going to be something that we could use because that was like 28 inches. It's going to be way larger. So our diameter cannot be larger than 18 inches. And I went ahead and I showed my students what 18 inches looks like. And they're like, oh, that's too big. We need to make it smaller. So my students liked the 10-inch diameter. That's what we went with. We chose to use 10 inches as our diameter. So we got our ruler, put it down on paper, and I made them do a cross. Okay, so they went across this way and up and down. Remember, because that's going to be the same. From the floor up is going to be the same as across the tire, which is the same diameter. So we're going to do 10 inches. All right, 10 inches that way. Move my ruler up and down. 10 inches this way. That, okay? So, and that's going to be our diameter. And try to get your students to draw a circle and make it circular if you can. If they cannot, I understand that is very hard to do, to make a 3D circle. It's kind of hard to do. So try to get it. If you can't, then work at it the best that you can. All right. And then the width. Going back to that dirt bike tire was about 4 inches in width. It wasn't very wide. And I told my students that's going to be closer to what we're going to be using. It says, NASA told us that it can't be larger than 12 inches. Well, that's a pretty big tire. Some car tires are not even 12 inches in width. So that's pretty wide. We got to think about how wide we want our tire. Again, that dirt bike tire was about 4 inches wide. So I'm going to go 5. I'm going to cut the difference. We did a 10-inch diameter. I'm going to do a 5-inch width. All right. 5 inches. And I just drew down here at the bottom. So I have all of these measurements on my paper. There's my 5 inches in width. And here's my height over here. The tread height. How deep do you want those tread marks to go? On the dirt bike, I think it was a 1/2 inch, a little bit more than a 1/2 inch. So I chose an inch. I figured that's not too deep. The sand paddle that we tested, we looked up how deep those treads are on a sand paddle normally, and they're like 2.5 to 4 inches in your height of that tread. So we don't want that. That sand paddle picked up a lot of that regolith, and we didn't want that. So, all right, 1 inch in height, tread height. So there you go. Got a tread height mark. And if they can put all this together, then allow them to do that and try to let them, make a 3D tire, drawing it out. I know that's going to be hard, but if they can, try it. That may be a challenge for your students to do. See who can come up with the best 3D tire there. All right, so now we talked about our tread pattern, and we had several different tread patterns that we looked at. We looked at V treads, we looked at chunk treads. The dirt bike had like little itty bitty marks on it. There was X treads. There's treads that go all the way across, and that sand paddle. And I had some students say that that's what they wanted. They wanted a thicker, like a sand paddle tread. And I had them draw that out, and that is not pretty at all, but we are not being artists. We are just sketching it out. So don't make fun of my tread patterns. So I'm going to draw several right here. Like I said, the dirt bike was like chunks. It was like squares and rectangles with little things sticking out. And I'll show you what it kind of looked like to me. So you could do like a V tread, and I tried to get mine to where they did not connect because that did better with our tire test. The ones that did not connect did not pick up as much dirt. There was like the dirt bike tread. That is my impression of a dirt bike tread with those little like 5-star marks. And then there was a sand paddle there as well. So like I said, try to draw it out the best that you can. We're not trying to be an artist. We are just sketching out our designs. And then follow the Tinkercad video. Watch that guy. He has lots of educational videos. Slow it down and work part by part. Remember, our focus is the tread first, and then we're going to put it together in a tire last. And that video shows you how to do that. There are some examples of some tread patterns. You could pull different tread patterns up on the board, and then you could kind of let everybody show theirs and tell why they think that one would work on the moon. Go into discussions. Go back to all of the research that we've done and see which ones they think would be the best. But I hope you do well with this. I hope you had fun with this. I hope you design lots of different tread patterns, and you could make as many of these tires as you want to. You could challenge each student to come up with 4 different ones, 4 different tread patterns, 4 different sizes, see which one might work the best. If you don't have Tinkercad and you haven't worked in those CAD programs, let them just draw out several different tires. Just do what you can. We want to just get these students thinking like scientists, thinking like engineers, looking at our problems and trying to fix them and trying to solve them. So design as many tread patterns as possible. Send them in. Send your brochure into NASA. I cannot wait to see the pictures of you guys doing this. I cannot wait to see your designs that you came up with. If you have a Tinkercad account, you can download those and forward those on and have links so we can click on those and look at them. We may end up using one. One of those may go to the moon one day. Stick with NASA Hunch, and you guys may see one of your designs on the moon here in the distant future. I cannot wait to see what you guys come up with. I hope you had fun with these. I know I did. My students did as well. See you later, guys.